So chapter 5, we're continuing talking about polar coordinates, and later we'll talk about vectors. And section 5.2 is polar equations and graphs. So the first objective is going to be to graph and identify polar equations by converting to rectangular equations. So just as we can convert points, we can convert equations. So graph and identify polar equations by converting to rectangular equations. So then we're going to look at how to graph polar equations using a graphing utility. And then the third objective is to test polar equations for symmetry. And then the last thing will be to graph polar equations by plotting points. So you will need polar coordinate graph paper, and I give you some in class, but if you need more, here's the link to the free graph paper that's available. So first, we're going to graph and identify polar equations by converting them to rectangular equations. So here's some examples. A line in polar coordinates looks like theta equals 2 pi over 3. So because you don't see r, it means r goes through all possible values. So this means r is an element of the real numbers. It can be any real number. So we go to the angle 2 pi over 3 and say, well, you can be 1, 2, 3, 4, 5, 6, 7, any distance positive away from the pole. But then you could also have negative values of r, which would take you the other direction through the pole. So do you see how you end up drawing a line? And we can figure out the slope of the line now that we notice that, oh, the tangent of the angle 2 pi over 3, that would be the slope of this line if it was transported into rectangular coordinate system. Okay, so that's the equation of a line. Theta equals some number, and you don't see r, so that means r takes on every possible value. So let's look at a horizontal line. R sine theta equals 5. So we usually solve a polar equation for r, and then you can make a chart, pick values of theta, and find the r that corresponds, and then plot the points. So let's look at what happens. If theta is 0, r is undefined. So we can't draw a point for that. But let's keep going and say, well, let's pick the easy points. So if I do pi over 6, the sine of pi over 6 is a half, so it's 5 over a half, which is 10. So at the angle pi over 6, we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 concentric circles away from the pole. Okay, and then let's skip pi over 3 because that would be a kind of a goofy decimal, but we'll come back to it in a minute. So what if I have pi over 2? Well, now the sine of pi over 2 is 1, so I just get that r is 5. So when the angle is pi over 2, I go 1, 2, 3, 4, 5 away from the pole. So then if I have 5 pi over 6, the sine is a half again. So at 5 pi over 6, I'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then if you do fill in some additional points and do the decimal approximation and plot them, you'll see that this is the straight line y equals 5 because r sine theta is y. So this is the equation for a horizontal line. So remember I talked about that if it's a rectilinear sort of a thing like a line, it has kind of a clunky polar description and a simple rectangular description. So let's look at a vertical line. And we see that we can write this as r equals -3 over cosine theta. So we can pick values of theta and calculate values of r. So now when theta is 0, cosine of 0 is 1, so we get that r is -3. So at angle 0, I go backwards through the pole, 1, 2, 3, to get a point that's on my line. Then let's use the easy values of theta for calculating when it's the cosine. So we'll do pi over 3. So the cosine of pi over 3 is a half, so I have -3 over half, which is -3 times 2, or -6. So when my angle is pi over 3, I go backwards through the pole, 1, 2, 3, 4, 5, 6. And then you can see that you're not going to get any value at pi over 2 because the cosine of pi over 2 is 0, so r is going to be undefined there, so we can't find a value. But let's keep going around and say, let's see, what if we get to 2 pi over 3? Well, now the cosine is -1/2, so you're going to have -3 over -1/2, so that's going to be +6 when theta is 2 pi over 3. So 1, 2, 3, 4, 5, 6. Okay, and you can plot additional points if you like. You can do the 7 pi over 12 and the 3 pi over 4 and get decimal approximations, but I'll just tell you that it's going to make a vertical line. So it's a vertical line that has a really simple equation in rectangular, x equals -3, and it has a more complicated looking equation in polar, but we can write it in polar. Okay, so now circles are much simpler in polar coordinates. So let's look at that. If we have the equation of a circle, if you haven't seen it before, this is the equation of a circle called in standard form, where the center is hk, so notice the minus is in the formula, and then positive h, positive k is where the center of the circle is, and the radius is little r. So in polar coordinates, if you think about it, let's see, x squared plus y squared is r squared equals 4, and r is always positive, so it's r equals 2. So what a simple equation. That's the equation of a circle in polar coordinates because it's nicer to express in polar than it is in rectangular. It's much more complicated. So as theta goes through all values from 0 to 2 pi, r continues to be 2. So again, because the equation looks like r equals 2 and you don't see theta, that means theta goes through all its possible values. So r equals k is the polar equation for a circle of radius, this should be k, centered at the origin. So whatever that number is, that's the radius of the circle, centered at the pole in polar coordinates. We're kind of going back and forth between polar and rectangular here. So there are more ways to write circles in polar coordinate form. So if you write that r equals 2a sine theta, let's see why that makes a circle with the center shifted in polar coordinates. So we're going to do theta r, and this is I think also why it gets confusing when you go to plot the points and write their coordinates in r theta form. So you might want to do something to remind yourself that you put theta in first to find the r, but then when you plot the points and when you write them, it needs to be r theta. So when theta is 0, sine is 0, so we get that r is 0, so that means that the pole is a point on the graph. Okay, so then again, let's use numbers that give us easy to plot points. So if we have theta is pi over 6, then the sine is 1/2. So we get A. So when my angle is pi over 6, I'm a distance A from the pole. Okay, so then let's do pi over 2. And the sine of pi over 2 is 1. So once we get to pi over 2, we're going to be 2a. So whatever this distance is, we're going to be twice that far away from the pole. And then see how when we get to 5 pi over 6, the sign is still positive, and so you're a away from the center. And then if you keep going around, when you get to pi, that's going to be 0 again. And if you keep going to, say, 7 pi over 6, you're going to duplicate a point, because when you get to 7 pi over 6, the sign is negative. So you're going to get r is negative 2a. So when you're at angle 7 pi over 6, you go backwards, sorry, negative a. You go backwards through the pole and get to this same point again. So if you plot lots more points, you would see that this makes a circle with the center at 0, a. And we'll talk more later about how you can tell which kind of symmetry the circle has, and that makes it pretty quick to graph them. Okay, so these exercises first want you to transform the polar equation to an equation of rectangular coordinates. Then identify and graph it, and verify it using a graphing utility. So if you don't have Desmos on your phone or computer yet, you'll want to get that, because that's the easiest way I know of graphing them. Although you can also use the website wolframalpha.com and ask it to graph polar equations for you. So we have r equals negative 4 cosine theta. So let's make a little chart with theta and r. And I like to start with theta is 0. The cosine is 1, so r is negative 4. So when theta is 0, we go 1, 2, 3, 4 backwards through the pole. Okay, and then cosine, that'll be easy to calculate when theta is pi over 3. So when theta is pi over 3, the cosine's a half, so r is going to be negative 2. So I'm at an angle pi over 3, and the cosine is going to be negative 2. Okay, then pi over 2, r is 0. So we know the pole is a point on this graph. Then let's do 2 pi over 3, where now the cosine is negative, so I'm going to get a positive 2. So when I'm at 2 pi over 3, I'm getting a positive 2 for a point. And then you can fill in with more points, and you'll see that this is a circle with the center at what would be the rectangular point, negative 2, 0. So let's look back up here and say, oh, if you have r equals negative 2a cosine theta, then the center is at negative a 0. Okay, so we'll do this one in class because it has kind of a tricky little piece to it. And then objective 2, you can use Desmos or Wolfram Alpha for doing the graphing utility. So next, let's test polar equations for symmetry. And I'm going to make this a separate movie because I don't want to get this to be too long of a movie.